My talk is called Enabling Function Services by Laser Texturing, and this morning it was addressed several times how to bring innovative technologies developed at the university to the industry, and spin-off companies indeed play an important role there, and that's also why in this presentation I try to show that a little bit how we as a spin-off company are doing this, and how collaborative research projects help in this, and also how the I4MS initiative and the APPOLO project, what roles they have. So I'm not going into details of the technology, but more try to show you this, this route. A quick introduction of our company. We were founded in 2008 as a spin-off of the University of Twente, that's located in the Netherlands, and the M2I Institute. And at the university there was the basic of the technology developed, I'll show you later. And as a spin-off we try to further develop that towards industry on a little bit broader scale than I show in this presentation. We work on material processing with ultra-short pulse lasers, and that can be micromachining processes like you see in these two examples. So for example for microfluidics. And in this presentation I focus on functional surface textures. That's kind of another application. What we offer is process and application development, because these processes are really new and customers need to see them, and we need to demonstrate them and develop them. And finally we produce machines for production and also for R&D. So what are functional surface textures, and why are they enabled by these lasers that we are using? Here I show you 4 functions of surfaces that can be improved by lasers. First is wetting, and we've shown that with very fine surface textures on a micro and nano scale that can be made by ultra-short pulse lasers, it's possible to imitate the lotus effect that you see here. So this is a micro nano textured surface that we made, and here you see a bouncing droplet, and that could be used, for example, for kind of self-cleaning surfaces or other applications. Then friction and lubrication is the next. A bit too fast. Is the next topic. By changing the surface texture, you can improve or reduce friction and improve the lubrication for technical parts, but also for skin friction. That's actually the topic that we're working on in the APPOLO project. You have optical effects because we can make structures in the order of the wavelengths of visible light, so you can create very nice optical effects. And also there are biomedical applications where you use surface textures to change how cells adhere to a surface. Now I go a little bit more into the wetting, because that was what was developed at the University of Twente. I also worked there as a researcher on that topic. And there we textured surfaces into a mold, into a steel mold, and then by injection molding we were able to replicate these textures. So we used a very expensive technology to make a master surface, and then a mass production technology to make cheap parts out of that with a functional surface. But that was really on research scale. We could only make very small surfaces, and it really had to be scaled up to be usable. And then there comes the first project that we worked in. That was the Nano project under FP7. And there the goal was to fabricate super hydrophobic surfaces for automotive parts, automotive plastic parts. And there you obviously have to be able to machine large areas and 3D curved areas. And that was also the biggest challenge for us, to develop the technology towards 3D texturing. These are the different technological problems, or at least some of them, that you have to solve, and that we finally solved. So one is the machine, of course. You need to access quite complex surfaces. You see here a 5-axis manipulator robot that was specifically made for this technology, and a galvo scanner integrated. So this is a scanner with fast-moving mirrors that manipulates the laser beam on a small area. If you want to machine a big area, a curved area, you have to use this 5-axis machine to position these two parts towards each other. Then there's a lot of sensor systems that we need to calibrate the position, for example, of a mold in the machine, but also to align the laser beam that travels through free space along moving axes, and that all has to be very accurately aligned. So you really need sensor systems, and you need software to handle that. And that's actually the most important part, I think, in these kind of systems, is the control software, and that's where I think 75% of our effort goes into. And the second part is, or the secondly important part are the laser processes themselves, of course. You need to develop very special processes for these kind of applications. But as said, I think the control software is even more important because that's actually the enabler of doing complex things. So here you see a result of that technology. I'll show a video shortly. Just quickly before that, this is a shape that we want to texture. It's a mirror cap mold, and it's difficult to see, but this is distributed into 25,000 single, very small tiles, and they all have to be textured. And that also, yeah, is big data. There are 32 million single texture elements that we have to machine, and that all has to run in an automated job. What you see now is highly accelerated, so the machining the complete mold took 50 hours, and this is, I think, 100 times accelerated. And yeah, you see the mold gets black on the left part, so that's the texture part, and the right part is still shiny, polished. What we are making here is this combined micro-nano texture into the mold that later will be copied into polymer by injection molding. So this again is a picture of the textured mold. You see some optical effects inside these textures. And these are the injection molded mirror cups that were done by the partner in the project. And you see a quick test. We dropped some water onto that part and it really splashes off as was the intention. So this is the state of research 2 years ago, 2012, when we finished the NanoClean project. Oops. And now I come to the APPOLO project because that's a very nice successor of the developments that we've done so far, because APPOLO enables us to, again, use the same technology as a basis to make a functional surface, again, in injection molds, but now to create functional parts on car interior, in the sense that we create surfaces with a very smooth touch, a silky touch, and also an anti-glare effect. And the basic technology is again the same, but here we try to develop it further, and at the end of the project it really has to be industrialized and has to be, yeah, the industry has to be able to use this technology to texture molds at the end. So that's the optimization of the technology for the soft touch surfaces on the one hand, so we have to look into which textures perform optimally in combination with polymers and in combination with the injection molding process. That's done in collaboration with CRF, the Research Institute of Fiat. We optimize the laser source together with the laser manufacturer time bandwidth products. Also the Bern Applied University helps there. And yeah, with these partners, we optimize their technology. And what we do inside Leitmotiv is really optimization of all these aspects of the machine that I showed before. Then I also want to show a related subject. This is a commercial project that we are working on. So the technology developed in these research projects can be used also for different applications that are closer to actual application. And this is also a texturing job. So we texture surfaces with these kind of dimple textures to improve lubrication here in the automotive part. I cannot tell you which part exactly, unfortunately. But if all these parts would already have this new technology, it would save billions of tens of billions of kilowatt hours per year. So again, a functional surface texture with a high potential, but it also here needs texturing of complex curved surfaces. That brings me to the summary. So we develop new kind of production technologies for very innovative applications that are quite complex, that take year-long development. And we have performed a significant part of these developments in FP7 projects. So first in NanoClean and now in APPOLO. And that enabled us to really keep the focus on these developments and not go for short-term profits, as if you would have an investor that wanted to do that. But we were able to focus on these developments. And the technology already pays off, so there are commercial results that are now implemented. And I wanted to only give you one idea for the future. I think these machines are only getting more complex on the inside. So they are getting more integrated, more sensor technology. We want to make these processes even more precise. And for that, we need adaptive machining. I think that's the most important step for these machines that we see in the future. From the outside, they will be simpler and more reliable and more accurate, but on the inside more complex and more ICT. And that's my, that was my talk. Thank you.